Okay, for this question, we've been told that 100 mLs of 1 molar hydrochloric acid has been titrated with 2 molar sodium hydroxide, and they've given us this beautiful strong acid, strong base titration curve. They want to know how would this curve change if instead of using the 2 molar sodium hydroxide, we used 1 molar sodium hydroxide. Well, the key to these types of problems is you don't want to go ahead and do all the calculations over again, and you don't need to. What we want to do is just do some generics. You want to focus in on the main points of these titration curves and think about how would those points change. Then you can just kind of sketch the in-between. All right, so if you have a strong acid, strong base titration curve, there are 3 general areas that you want to focus in. You want to look at the starting points, you want to look at the equivalence points, and then you want to look at the ending points. So let's begin with the start. So my starting pH is 100% dependent upon the acid that I have. I have a 1 molar hydrochloric acid, so we're starting at a pH of 0. Now, if I use 1 molar sodium hydroxide instead of 2 molar sodium hydroxide, that is not going to change. I haven't added any sodium hydroxide yet. So our beginning pH remains exactly at the same point. The next piece you want to examine is the equivalence point. We want to look both at the volume that it took to get to the equivalence point, and we want to look at the pH at equivalence. Let's go ahead and start with the volume. If we're using a base that's half as strong as the original base, we're not going to get to equivalence as early. It's going to take us a greater volume of sodium hydroxide in order to neutralize those moles of hydrochloric acid. In fact, if we use 1 molar sodium hydroxide instead of 2 molar sodium hydroxide, it's going to take us double the volume. So your equivalence point is going to be shifted to the right. I'm looking at it now. Instead of being at about 0.05 liters, you're going to be at 0.1 liters. Now let's talk about the equivalence pH. Whenever you have a strong acid that's titrated with a strong base, well, the pH at equivalence is 7, regardless of the strength, whether it's a 2 molar sodium hydroxide or a 1 molar sodium hydroxide solution. So we're going to maintain the same pH there at 7 for this equivalence. Now, the last piece is the ending pH value. At this point in the titration, you've gone beyond equivalence, and now you're just adding excess sodium hydroxide, excess base. So we have a basic pH. Well, how will this change if we're using 1 molar sodium hydroxide versus 2 molar sodium hydroxide? In the end, you're going to have a slightly less basic ending pH, just ever so slightly. And the main reason is you're still going to have those excess moles of sodium hydroxide floating around, but since we're using more of that 1 molar sodium hydroxide to get to equivalence, we have a greater overall volume. Those excess moles of sodium hydroxide are floating around in more liters of solution. It's less concentrated hydroxide floating around. That means it's just not quite as basic, ever so slightly below. But otherwise, the general shape of your graph remains the same. We've just kind of stretched out this graph and maybe flattened the top bit or lowered the top bit a slight marginal amount. I hope that helps. Take care.